Okay, we're going to start 5.5 with looking at our multiple angle and power reducing formulas. These are the next two sections of identities. We're going to start with a solving. First of all, I'm going to use the identity to rewrite this sine 2x. I'm going to rewrite it with this identity right here. So 2 cosine x plus 2 sine, and my angle in this problem is x, times cosine x, and we know this equals 0. This turns into just your regular solving formula, or solving equation. They both have a 2 in common. They also have a cosine x in common. If I factor that, I have a 1 plus sine x left over. Now I can take my two factors and set them equal to 0. And when I solve them, I'm going to get cosine x equals 0 and sine x equals -1. So where does cosine x equal 0? Cosine is going to equal 0 where the x coordinate is 0. So up here at pi over 2, 3 pi over 2, we can combine that into one statement and say that's pi over 2 plus pi k. Where does sine x equal -1? That's where my y coordinate is -1. That's going to only happen in one place, which is 3 pi over 2. And that's going to land in this statement, so we only need to list one answer. Do the same thing here, except for use your cosine identity. Cosine identity, you do have 3 to choose from. I would choose the one that's going to make it least complicated, so since I already have a cosine, I would probably use the second one and substitute in 2 cosine squared x minus 1 into there for my cosine 2x. So work it out the rest of the way and then check. Okay, we put it all together. Now we substituted, put it in order, selected my factors, set my factors equal to 0 and solved, and found the angles. Okay, finding sine 2x, cosine 2x, tangent 2x. Before I start, I'm going to use this information given and create a triangle. This part of it tells me I am in quadrant 4. So I'm going to draw my triangle in quadrant 4. I know the cosine is 5/13, which makes my missing side 13 squared minus 5 squared is 144, so this side is 12. It is -12. And now if I answer the question, we say sine 2x equals 2 sine x cosine x, so this is 2. Sine of x is -12/13, cosine x is 5/13, and now all I have to do is do the multiplication. This is going to give me -120 over 169, which probably reduces, and nope, just kidding, final answer. Then we go on to the cosine 2x. At this point you can pick whichever one you want to. I'll pick the third one, 1 minus 2 sine squared x. So 1 minus 2 sine is -12 over 13. Make that squared. 1 minus 2 times 12 over 13. Square that. Gives us -119 over 169. And then finally we have to do tangent of 2x. Tangent 2x equals 2 tangent x over 1 minus tangent squared x. So this is 2 times tangent is going to be -12/5 over 1 minus 12/5 squared, and I'm just going to punch that into the calculator and get that answer. And I get 120 over 119. Okay, identify what quadrant this is in, draw your triangle, then answer the 3 questions. Okay, here's the answer. We set up our triangle in quadrant 1. And here's your sine 2x, your cosine 2x, and your tangent 2x, cosine 2x. I chose the last one. You can choose any one you want. You should come out with the same answer. Okay, now we're going to rewrite sine to the 4th x using our power reducing formulas. In this case, we're going to rewrite sine to the 4th as sine squared x squared. And then we're going to substitute inside the parentheses. So with the formula, 1 minus cosine 2x over 2 squared. Okay, when I square this, I'm going to get 1 minus cosine 2x times 1 minus cosine 2x over 4. I'm going to FOIL out the top, which is going to give me 1 minus 2 cosine squared x. Oh, they're cosine 2x's, not squared x's. Let's fix that. These are big 2's. So that gives me cosine squared 2x plus, oh, I'm sorry, minus 2 cosine 2x. There was 2 of those like terms, add them together. And now it's plus cosine squared 2x. And this is still all over 4. Now I'm going to substitute in for this guy the cosine squared. So let's scoot this up. Not quite that far yet. Okay. So now this is going to equal 1 minus 2 cosine 2x plus. Here's where I'm substituting in. Okay, when I substitute this in, 1 plus, where did my pen go? 1 plus is cosine 2u, which is doubling our angle. Well, since we're doubling 2x, this is going to become cosine 4x over 2. And this is still over 4. Okay, now I need common denominators across the top. So I'm going to multiply these two by 2 over 2. So this is going to give me 2 minus 4 cosine 2x. You're not multiplying the angle, just the coefficient. Plus 1 plus cosine 4x. Common denominator of 2, all still divided by 4. I'm going to multiply, instead of dividing by 4, multiply by 1/4. Do a little bit of combining like terms. Now I'm going to have let's start with cosine 4x minus 4 cosine 2x plus 3 all over 8. Okay, same thing with tangent. Start out with tangent squared, and then replace with your formulas. So what I've done so far was replace tangent squared, or tangent to the 4th, with tangent squared. I plugged in the identity twice, because it is squared. I FOILed the top, FOILed the bottom. Now I'm going to go through with some substitution on top and bottom with the cosine squared 2x. Okay, now I've made my substitutions. Make sure these are 4x's because they are doubled from a 2x. Now I'm going to scroll up here, do some simplifying. I need common denominators along the top and the bottom. So multiplied by 2, by 2, by 2, by 2. Here's what we're going to have. Okay, I've got my common denominators. when I multiply by my reciprocal, my 2's are going to cancel out. So now all I'm going to have is almost the same thing on top and bottom, but they are a little bit different. So now, writing top and bottom, I have a big expression over a big expression, but everything is written in terms of cosine of multiple angles.